In the last lesson, we learned how to read in our data set the difficult way to arm ourselves with some text manipulation tools, and then we learned the easy way using Panda's read CSV function. Now we're going to read that data back in the easy way. So again, we're importing pandas and storing it as PD, and then we're calling pd.readcsv, where all we have to do is pass in the name of the data set, so that's SMS spam collection.tsv, and then we have to explicitly tell it what the separator is. So we tell it \t, which indicates tab separated. And then lastly, we tell it that it shouldn't expect a header. In other words, if we don't include this, it'll just take the first row as the column names. And then we're storing that as full corpus. Now, as we saw in the last lesson, there won't be any column names. So let's go ahead and actually tell it what to name our columns. So let's call full corpus.columns, which just stores the column names. And then we can just simply pass in a list. So we want the label to be called label, and then we want the text message to be called body_text. Now let's go ahead and just print out the first 5 rows of this data frame. There it looks like just what we saw last time. Now, typically before diving into any in-depth analysis, data cleaning, or model building, we want to do some very high-level exploration of our data to understand what we're working with. So we might ask questions like, what is the shape of our data? How many ham or spam are in our data set? And are there any missing values? So this will inform the decisions that we make as we move forward. So let's start by shape. So this will help us understand how much data we have to build a model on and how many columns there are. To make this clean, we'll use print statements so that we can say input data has this many rows and this many columns. And then in order to fill that, we just have to do .format, and then we pass in the number of rows, which is filled simply by len full corpus, and that'll fill the first bracket. And then for the second bracket, we just have to do len full corpus dot columns, just like we assigned above. So then when we run that, it'll just tell us how many rows we have and how many columns we have. So for this data set, it's pretty obvious because we can just count the number of columns, but it's more important as you have a couple million rows and hundreds or thousands of columns, you won't really be able to count the number of columns. So this can actually be pretty helpful. Next, we want to know how many rows are spam and how many are ham. This is especially useful as we move towards machine learning. If something like 5,560 out of the 5,568 are spam, then we would approach this problem in a very different way than if it were a 50-50 split. So we're going to use the same format for the print statement as we did previously. So here we'll say out of this many rows, this many are spam, and this many are ham. And then again, in order to fill those brackets, we just do .format. And for the number of rows, it's the same that we did before, len full corpus. Now, in order to get how many spam we have in our data set, we'll go to a new line, and then again, we're still going to take the length, but we'll take full corpus, and then we need to filter the full data set to only include the rows where the label is equal to spam. And then we'll close off our length parameter. So again, what this is doing is it's taking the full corpus data set and it's filtering it to say the rows must have label equal to spam. And so that'll filter the data set down to only rows that have label of spam, and then you take the length of it, and that'll tell you how many of your text messages are labeled spam. So now we need to do the same exact thing for ham. So we can just go ahead and copy this filter statement that filters on spam, copy it down to the next line, and all we have to do is change this from spam to ham. So now this will filter your data set down to only the rows or text messages that have a label of ham. So let's make sure that all our parentheses are aligned. So just add one more parentheses to close out your print statement. And then you can run this, and it tells you out of 5,568 rows, 746 are spam, and 4,822 are ham. This is fairly lopsided. This is important information as you're starting to build your machine learning classifier, And even later on, when we start creating features, this will be useful to know. So we'll revisit this again in the feature engineering chapter. Now, lastly, we want to understand how much missing data there is. If we have text that's missing, then we won't really be able to use it to build a model if we're missing the actual body text. So we want to know that ahead of time. So again, we're going to use the similar format with the print statement. And this one will say number of nulls in the label and have that bracket. And then again, we do format. And in order to get the number of nulls in label, we just do full corpus label. And then we can use this isNull method. And what this isNull method will do is it'll look at the entire column of labels and return a true or false for every single one. So if label is present, if there's either spam or ham, then it's false because it is not null. And if it is missing or it is null, then this will return true. And then what we can do on the end of that is add .sum, and that .sum will just sum up all of the trues. So that will return how many nulls there are in label. Now we want to do the same thing for the text body. So we can just copy this where we did isNull for label down here, and we can just change this from label to text. And then we change the column that we're calling this on from label to body text, but we'll run the same thing isNull. It'll look for nulls and assign a true if it is missing. And then we sum up all the trues. So we can run that, and luckily we don't have any missing values, which is going to be really helpful. This lesson helped us better understand our data once we actually got it read in. The insights pulled from this very basic exploration will help dictate how we approach the rest of our data cleaning and model building.